All right, so we're talking about exponents today. The first thing is an exponent. Okay, an exponent is a small superscripted number. Okay, that shows how many times a symbol or a number is to be multiplied. Okay, what's superscripted mean?
It's like tiny.
Okay, it's tiny.
It's at the top.
It's at the top, as opposed to, what's the other word? Using chemistry.
Coefficient.
No.
Wait, no.
Coefficient.
No.
Say again? Subscript, I heard it, yeah. Subscript. So superscript is at the top. Subscript is at the bottom. We don't deal with a lot of subscript in Algebra 1. You'll deal with that more in Algebra 2 when we talk about logs and stuff like that. Okay, so basically, if you're looking here, this is our exponent, that 4 right there. Okay? But that exponent tells us how many times we're going to multiply something. So right here, what you're going to do is you're going to identify your base, and then you're going to identify your exponent. Okay? So the base is 2, and the exponent is 4. Okay? Over here, your base is x, and your exponent is 5. Now what this means, if I was to break this down, okay, that 2 to the 4th power really means 2 times 2 times 2 times 2. And just like this, same thing with x to the 5th power, it's x times x times x times x times x. Okay? Okay, now, the one thing that's confusing about this, or students make mistakes, not that it's confusing, but students make mistakes on this on a regular basis, is the fact that they'll take this x times x times x times x times x, instead of making it x to the 5th power like it is, they'll make it 5x. Okay, what is 5x?
5 times a number. No, it's just 5 times.
What does 5x represent?
5 times x.
No. Yes, it is 5 times x, but what does that really represent? 5x is how? Because that's 5x's too, right? 5x is multiplied as what?
5x.
No. X to the 5th. I just showed you what 5x is multiplied is. 1, 2, 3, 4, 5, all being multiplied. That's x to the 5th power.
So 5x is 5 times x.
Which we've established that already, but what does that mean?
Like, whatever the x is, it's like...
Okay, what does 5x mean?
Multiply x
Just
by
tell us.
5.
No.
I don't know.
Wait, 5x would be 5 times x.
Would it be like 5 times? That's what we just said,
No.
Nathan.
Is it coefficient?
Then tell us.
I already told her that yes, it's 5x's, but how is it 5x's? It's not multiplied because that's x to the 5th.
Plus, they're
Added together. 5x is added together. Okay, so x plus x plus x plus x, okay, is 5x. It's 5x is added together is 5x. Not to be confused with x to the 5th power, which is x times x times x times x. Okay? You made that much more complicated than it needed to be. Okay, so here's where you're going to start your memorization process.
Bless you.
Okay, we got it. Thank you. Okay. Okay, here's where we're going to start to memorize our stuff.
Bless you.
Okay. The law of zero exponents is this right here. If I have 2 to the 0 power, okay, what do you think that is?
0.
Okay, wrong. Okay, in your calculator, do this. Okay, 2.
No, it's 2.
Okay, just do this first, please. 2, rooftop. That's this rooftop button, or some people call it the caret. I'm not sure why, but it's a rooftop. Okay, it's underneath the clear button. Okay, to the 0 power. I said, just please do this, so that everybody else will do it. So 2 to the 0 power, okay, is 1. So what the law of zero exponents is that any exponent or any base to the 0 power equals 1. So any base to the 0 power equals 1.
So it could be like 1,000 to the 0 power and still be 1.
That's right. So if you wanted to do 5,280 to the 0 power, it would still just be 1. Okay? If you do y to the 0 power, what is it? 1. There's where a variable will actually turn into a number, because y to the 0 power turns into the number 1. Okay? Okay? Same thing. All right, exponents to the first power. This is what we call the identity property. Okay? So if I take 2 to the first power, what do you think that is?
2.
It's 2. Okay? Every number you have is actually raised to a power. We just don't look at it. 1 is universally understood, right? So if I have x, I really have 1x. Okay? Not only do I have 1x, but I have 1x to the first power. Okay? We just don't write all those 1s down because they're not necessary. But when we start adding and subtracting exponents, which we will do, you'll need to know that that 1 does exist. Okay? So, any base to the power of 1 equals the base. Okay, so if I do 5,280 to the power of 1, it equals 5,280. Okay?
That's what the equals.
Yes, it does. Okay, any questions on that? Okay, and for right now, we're going to skip this part here because I have no idea what they're talking about, x to the a power. So we're going to skip that for right now. Okay?
Sounds hard.
Could that be,
It's not hard. I don't know what it is. Negative 3 times 5. And then our a bases, which are a squared times a. And then our b bases, which are
b
cubed.
B
to the fourth power.
So times b to the 4th power. Okay, so let's go ahead and start simplifying. Negative 3 times 5 is negative 15. A squared times a is what?
A3.
Okay, A3. Okay, you've got to, this is where that 1 comes in, right? Because I said, what you don't see now is that there is a to the first power. Every number has an exponent. So that's a to the first power. Okay, and then you add the number. So it's a to the 3rd power. And then b to the 7th. Because for some people, 3 plus 4 is 7. Okay. What were you going to say?
I was going to say in our answer, we don't, that's our answer, right?
Right there, where that box is our answer. So you stick it all together now. Okay?
This is easy smeechy.
Okay.
Don't say that.
No, it's actually really easy.
Yeah, this is.
This is like 8th grade.
Okay, so what is x squared plus x squared? What'd you say, Kira?
2x squared.
2x squared. Notice the different operation. We're not multiplying here, we are adding. Okay? And since there's 2 of them, it's just, these are like terms, right? 1x squared plus 1x squared is 2x squared.
So you don't add the 2
So that's
squares?
number 4 too.
No, why not?
Number 4 is.
Hang on. Let's not jump ahead. She's asking a question that I think a lot of you need to know the answer to. Why are we not adding the exponents? Huh? Because it's adding. We're adding the 2 things, the 2 terms. We're not multiplying the 2 terms. We're just adding the 2 terms. That's why I circled that big addition symbol. Since we're adding, okay, we don't multiply the 2 terms together. Now, 4 it looks the same, except now our operation is what? Multiplication. So x squared and x squared, those are the only terms we have, come out to be x to the fourth power. And you can also write it this way for those of you who need to break it down more, x2 plus 2. You'll see this in textbooks a lot, and that goes to x to the fourth.
I thought we don't use textbooks.
You should, but we don't.
Oh, okay.
Okay? But I'm just saying, in general, when you go to college, you'll use textbook. When you get to Algebra 2, you'll use textbooks. And you'll see this, where they'll actually break it down to 2 plus 2.
Because x times x is x. And 2.
No, x times x is x squared. When you multiply like basis, you just add the exponents. Here's the deal with this section. There's nothing to get. Okay? I like when I hear students say, I don't get it. Sometimes it's fine because it makes sense, because we do operations that are crazy, and then you say, I don't get it. On this particular thing, there's nothing to get. It's simply memorizing the laws. And the law is that if you have like basis, x and x, when you multiply them, you add the exponents. That's it. There's nothing to get to that. It's just about memorization. And it takes a little while to get used to, because you have to memorize that. Okay? Yes? And to yes.
Oh, okay.
That's why I broke this out for you. These are like bases.
Okay.
These are not. Those are the coefficients. Why are these not bases to anything? Or let me correct myself. Let me be more mathematical. Is 3 a base to something?
No.
It is, but what is it? It's a base to 1, right? Is 4 a base to something? Yeah, it's a base to 1, okay? But essentially, this isn't what we would consider a like base, but these are because we have n raised to the second power and raised to the fourth power. You see that?
So, like whatever power is next to the number, the base.
Oh my god.
Yes, whatever. Okay, the base is always the letter or number, always the letter or number that is attached to the exponent. The 3 is not attached, right? So it's always a letter or number attached. All right, let's look at number 5. On number 5, what's our answer there?
3x to the 7?
Does the exponent have anything to do with it?
No.
No?
It's adding.
You're doing adding, so what's our answer?
2x, 3x.
2x.
Square.
Nope.
Okay.
Nope. 2x to the fourth power plus
X cubed.
x cubed. That's our answer.
What? That's the same.
Why can it cannot be simplified. In your textbook you'd have homework like that you would just write. It cannot be simplified. Why can it not be simplified? What's our major operation here?
They're different and adding.
We're adding. And since we're adding, in order to add, we must have what?
Same base.
Common
No.
exponents.
No.
No.
In order to add, we must have.
Same base.
No.
Numbers.
Go way back to first 6 weeks.
have the same exponent.
Okay.
I already said that.
Okay, I'm asking, and technically you do have to have the same exponent, but you're missing my point here. In order to add, you have to have what kind of terms? Like terms. You have to have like terms. Do we have like terms here?
No. We were saying.
No, it's not exactly what you're saying
That's
at all.
exactly what I was saying.
Okay,
Yeah.
I'm not going to argue with you. Okay, in any
well, I know
case,
what I was saying.
you have to have like terms. Like terms means that everything is the same. That means you have the same variable with the same exponent. So in this case here, we don't. So those of you guys who are saying you need to have the same exponent, it's true, but you didn't understand why. And the reason why is because it's not because we need to have the same base, because we have the same base, okay? But we're adding, so it doesn't matter. We're not multiplying. And so in order to add two things together, you have to be like terms, common terms, okay? All right, so going on to the next one. What are we doing here? Multiplying. So can I multiply these together? Yeah, you can multiply anything together. So let's take out the coefficients. What's my coefficients?
2 and 1.
2 times 1. Okay, and for some, let me take a time out for just 1 second. Some of y'all just need to listen. I know I'm asking questions and I would like for answers to come back, but some of y'all just need to listen first before you answer. Okay, and I'm not trying to be mean or anything, but some of you answer wrong every single time, and it hurts your learning process. So I need you to listen sometimes too without answering, and you'll learn just as much. Does that make sense? Okay? Especially when you're just learning. Okay? So 2 and 1 are my coefficients. Okay? And then I have my exponent, which are x to the 4 times x cubed. Okay? So 2 times 1 is 2. X to the 4th times x to the 3rd is x to the 7th. So here's where we have 2x to the 7th, where some of you guys are trying to answer that last problem. What we're trying to do here is establish where you understand the difference between adding and multiplying. Adding and multiplying. You guys see the difference? And see how hugely different the answers are. Okay? Alright. Let's look at number 7. What do we have to do here?
Solve what's in the parentheses first.
Okay? True, but can we solve? No, because why? Why can't we add AB minus 3A squared B 5?
It's not like terms.
They're not like terms. So we can't do that. So then what do we need to do, Kira? We need to distribute the 2AB. We need to distribute the entire thing. So I'm going to take this entire thing and distribute it to the AB and distribute it to the negative 3A squared B to the 5th. So let's go ahead and do that. So we're going to break it into a simple problem. So 2AB times now AB. And then over here we're going to have our own problem with 2AB times negative 3A squared B to the 5th. Everybody see what I did there? I'm just showing you the work for distribution. Normally you wouldn't show this step, so where you learn distribution to this point, but now I'm showing you the step. That should be AB, by the way, not 2A. But now I'm showing you the steps so you can see I'm multiplying this together and I'm multiplying this together, and here's the in between.
Oh, okay.
Okay? So then what are my coefficients on this first side right here? 2 times 1. Then I have A times what?
Just be AB times AB or A.
No, let's just go. We're going to break it down. A times A and B times B. So when I simplify this, I have 2. What's A times A? A squared. Because remember, we have the variable 1, the exponent of 1 here and the exponent of 1 here, right? So what is B? B squared. So now I have 2A squared, B squared. Over here, we'll break it down. What are my coefficients? 2 and negative 3. Then I have A times A squared. And then I have B times B to the 5th. So when I simplify this, 2 times negative 3, and once I start to simplify this, I'm just going to stick it right back here with the rest of this problem. So 2 times negative 3 is negative 6. A times A to the 3rd power, A to the 2nd power is A cubed, or A to the 3rd power. And B times B to the 5th power is B to the 6th power. And there's your answer. Are there any like terms that I can combine in here? Because you always want to look to see if you can combine like terms. No, these are still unlike terms because now I can't subtract 2 and 6. I can't pull those away from the variables because these are still coefficients of variables. And since this is A squared, B squared, this is A cubed, B to the 6th, they don't combine. Did we follow that? They're not like terms. Okay, I'm going to go ahead and erase this so I have more room to work over here. Let's look at number 8. Okay, number 8. When we multiply fractions, how do we multiply fractions? How do we do it? No, you don't have to flip anything or anything like that. When you multiply fractions, you just multiply what? Straight across. What were you saying? Oh, she was trying to get rid of the denominator. Okay, I'm not trying to get rid of the denominator by multiplying the denominator through, but like somebody over here said, multiply straight across.
Just by the okay.
No, we're not doing the
No,
reciprocal.
no, I know, but to get rid of the denominator.
Yeah, except not here, because there's two reciprocals.
Oh, I was just saying in general.
Okay, yeah, well here, that's dividing fractions,
Yeah.
is what you're thinking of. Okay, so we're going to multiply straight across. So the bottom's easy. We're just going to put a pin in the 3 times 5, because we know that's what? 15. So we'll come back at the end and put 15 in the denominator, okay? So the first thing we want to do is do what? 20 times 12 times
X squared times x cubed.
x squared times x cubed times,
Y to the
so times y to the 5th. Let's go ahead and simplify that. 20 times 12, 240. Okay. X squared times x to the 3rd, x to the 5th. Okay. Y times y to the 5th, y to the 6th. All over what? 15. Now, when you have that, I know it's hard to see now because it's in the way, but you should have it written on your paper. Now you have 240 over 15. You can multiply and divide anything. Okay? So I need to reduce then. So to reduce 240 divided by 15, somebody would do that for me. What? What's 240 divided by 15? 16. So what's going to happen is that 15 is going to cancel out and become 1, and 240 is going to become 16. So my final answer then is going to be 16
X to the 5th, Y to the 5th
over 1. Do we need to put over 1? No. So it's just 16 x to the 5th, y to the 6th. Okay, any questions on that?
No, sir.
All right, let's look at number 9. Okay, number 9 we have 5x cubed minus 7y plus 8xy plus x cubed minus 3xy plus 4y to the 5th power. Okay? Is any multiplication taking place here? No. So what do I need to do in order to simplify or solve this problem? I need to find like terms. Okay, and I showed you this a long, long time ago, but I'm going to bring it back right now. We're going to do the circle, box, triangle method. Okay? It's been a long, long time. It might not have shown all of you. Circle, box, triangle method is basically this. I'm going to circle my first term. Not like that.
Oh, I remember.
Okay, so it's 5x to the 3rd power. I need to circle all terms that are the same as 5x to the 3rd power. So what other term do I have that's the same? X cubed. Okay? Is there any other ones?
No.
No. Okay, it's the same because you have an x cubed and you have an x cubed. That makes them the same. Okay, so now what I'm going to do is I'm going to box the next term. And I'm going to include the sign. So negative 7y. I need to box any other term that looks like it.
4y to the 5th power.
Okay? Does 4y to the 5th power count?
No.
No y.
It's not like terms.
It's not like terms. Why?
It's the exponent.
Because the exponents are different. This is a 1, this is a 5. 1 and 5 don't go together. Okay, so are there any other terms that go with 7y? Sorry, that go with negative 7y? No. Okay, so let's go to the next one. Okay, we're going to put a triangle around the next one. And you need to try to get your sign in there. So 8xy. Okay, and then you have negative 3xy. Do they go together? Yeah. Okay, where does 4y come into play? It doesn't, right? And we ran out of fancy shapes to use, so what I'm just going to do is simply underline the last one. Because that's all by itself, right? So now our next step would be to do what? Combine your like terms. Okay? So 5x cubed plus x cubed is what? 6x cubed, right? So 5x plus 1 more makes 6x cubed. When I'm done with these, I like to mark through them so I don't do them again. Okay? Do we have a pair or somebody else for negative 7y? No, so we just bring it down. So okay, what about 8xy minus 3xy?
5xy.
So now you have 5xy. Is it positive or negative? Positive, very good. And then what do you have left?
4y to the 5th. Which is 5.
So you have 4y to the 5th, which...
Was that our answer? Yes.
Okay, so that's your answer. And we'll talk later on about putting these in order based on their terms. And we'll talk more about that later. Okay? Ow. All right, let's look at number 10. Okay, it says find the perimeter of the area of the figure below. Okay, so how do I find the perimeter? You add up all the sides. Okay, so
Is it talking about?
I think it's talking about the whole thing. So we'll just go with the whole thing.
That's weird.
Okay? So this side here we know is 5 BC. That's this side, right? Then we have a BC. Then we have a BC. What is this?
That's 3 BC.
That's 4 BC.
That's to another.
I was actually talking about the
Okay.
side, which is
What's this side?
3 BC.
Okay, how do you know it's 3 BC?
There's BC's on the side.
Yeah, because here we have a BC right here, right? That's missing from here. We have a BC right here. That's missing from here. And this whole thing is 5 BC, right? You see that? You don't even look at it. You see that?
Yeah, I was writing it.
Okay, so 5 BC minus this piece here and minus this piece here makes 3 BC. Okay, everybody follow that? Okay. All right, so now and then this side up here is what? BC. So we've labeled all of our sides. So let's find the perimeter. So how am I going to find the perimeter? Okay, so start. 5, 5.
6.
I don't see a 5 up there. 5 BC, thank you. Plus,
4 BC.
well, let's go in a nice order so we don't miss anything. So plus BC, plus BC, plus 4 BC, plus 3 BC, plus 4 BC, plus BC, plus BC. Now, are they all like terms?
Yes.
Yes. So now you can do 5 plus what here?
4.
What's the second term? 1. Okay, so 5 plus 1 plus what? 1 is 7 plus 4. Okay, is 11 plus 3. 14 plus 4. 18 plus 1. 19 plus 1, which is 20. So our answer is 20 BC. Okay? Now, if I want to find the area, what do I do to find the area? What am I going to multiply?
Length times width.
Okay, so let's find the area of this one. The black one. 5 BC times BC. So what's the area of that one? 5 BC. Okay, let's go back. Is it BC squared?
B squared C squared.
B squared C squared. 5 times 1, right? B times B is B squared. C times C is C squared.
Our answer is 5.
So the area to that one is 5B squared C squared plus, what about the other one? 4 times 3 is 12. B times B is B squared C squared. So then our answer is 17B squared C squared. And that does it.